Good morning, chemistry class. Welcome back to Mr. Bennett's backyard chemistry lab. Got our Cyrus, our kitty here. He just caught a rodent. He's enjoying being home. Us being home, that is. How you doing, kitty? Today's lesson is on acids and bases and a little bit about salts. Just going to go over the basics today. Shouldn't take too long, but should take some careful notes here. Most of you have heard of acids and bases and you have some experience with it. So we're going to go through some different characteristics of acids and bases just to kind of compare them. First of all, most of you know acids, like lemons, tend to taste sour. Yeah, sour. And bases, and I'm not going to taste a base here, but they tend to be bitter. Touching, when you touch a base, such as, and cleaning products like detergent for cleaning your dishes are a base, they tend to be, they feel slippery in your fingers. Or if you get bleach on your hand, it feels slippery. Slippery. Whereas acids just feel wet, and if you happen to have a cut or something on your hand, and you got an acid on it, it would sting. So let's just say it would sting a cut. pH, that's a number system, and we'll go over that later, but in general, an acid has a pH that's less than 7. Base has a pH greater than 7. 7 is neutral. And then litmus paper, when you put acid, you put a piece of litmus paper in acid, it tends to be red, whereas bases tend to be blue. Ionizes in water, that means they divide up into positive and negative ions when you put them in water, and they both do that. So that's a yes and a yes, they both ionize. Acids and bases both ionize. Electrolytes mean they conduct electricity, and both acids and bases do conduct electricity. Reacting with metals. Acids do react with metals, bases no. Now these are some old-time chemists' definition of acids, and I'm just going to put them down there. We'll talk more about them later. But the Arrhenius definition of an acid is it's something that releases hydrogen ions into water. And a base releases hydroxide ions into water. So hydrogen ions into water, hydroxide ions into water. Then the Bronsted-Lowry definition. These are called proton donors. And these are proton acceptors. And the formula of acids tends to be H and something. And a formula of a base tends to be something than OH. So for example, HCl or NaOH. So hydrochloric acid has HCl, and then sodium hydroxide is NaOH. So that's the general formula for those. Now I want to go into a little more detail on comparing acids, bases, and this time salts. So, now the question first here is, of acids, bases, and salts, which ones are ionic compounds? They all are ionic compounds. So we'll just say yes, yes, yes. Now remember, ionic compounds are made up of a positive ion and a negative ion, cation and an anion, and each one sort of looks a little different. So an acid the positive ion is always an H. And the negative ion is a non-metal. So, for example, HCl or HBr or H2SO4, sulfuric acid, hydrochloric acid, hydrobromic acid, sulfuric acid, or your favorite that would be acetic acid or vinegar, C2H3O, C2H3O2. So those are some acids. Bases, the positive ion is a metal, and the negative ion is a hydroxide. So I should put a plus here and a minus here. And so some examples would be sodium hydroxide, potassium hydroxide, calcium hydroxide, and even ammonium hydroxide. Even though ammonium ion is not a metal, it acts like a metal. Okay, and then salts are going to have a positive ion that is a metal, and the negative ion is going to be a non-metal. We've talked about this before, but we're reminding you there. And examples: sodium chloride, magnesium oxide, and we could list 1,000 of them, but we'll try a couple. So let's take silver, nitrate. There's a few. All right, well, so that's it for today's lesson, and thank you very much for joining me.